Alright guys, I'm gonna try and record this for the third time. Hopefully I'll do it correctly. Okay guys, so here we have just a little refresher on the top what absolute value is. Absolute value is the distance that a number is from 0. So it doesn't matter if it's a positive 3 or a negative 3. The distance from 0 is still 3. So think of absolute value as a measure of distance, where we're not going to have negative miles, right? You're not going to travel negative 3 miles. You're going to travel 3 miles to the east and 3 miles to the west, you know? Excuse me. Sorry, something like that. All right, next thing is we're going to introduce to you the parent function of absolute value functions, where it looks very similar to the linear parent function, but instead of it just having y equals x, it has y equals the absolute value of x. Remember, f of x and y are the same thing. Okay, so we know that if it's a positive or a negative inside the absolute value sign, it doesn't matter. Sorry, guys. We end up with a positive value no matter what. Excuse me. So when we graph it, on the right side, when I put a positive 1, I get a positive 1. And then a positive 2 gives me a positive 2 and 3 and 4 and so on. But on the left side, I still get positives even though my x values are negatives. So it ends up creating a function that looks like a V, where the bottom part is called the vertex, or the lowest point. In this case, which would be a minimum, would be here at 0, 0. So that's our vertex. If this if this function was opening downward, then the vertex would be the maximum, not the minimum. But because this vertex here is our lowest point, it is called a minimum. Sorry about my cough. All right, and then the next thing is we need to know is the axis of symmetry. The axis of symmetry is the line that goes right through the middle or the center that creates a mirror image from left to right. So in this case, it would be the line that goes right down the middle of the absolute value function, where the left side looks exactly like the right, and that value goes right through the 0, where x is 0. So that's why our axis of symmetry is x equals 0. And it always is a vertical line. Next part. So this part is a refresher. Domain, we go left to right. Right? And if you see our function for the parent function of absolute value, from left to right, I can actually keep going and going on forever. If I plug in a positive 7, I'll get a positive 7. If I plug in a negative 7, I'll get a negative 7. So I'll keep going forever to the left, forever to the right. That's why our domain is negative infinity, positive infinity, or all real numbers. Pretty much, if you're not sure, this is the answer, okay? They give you a function with absolute value, then more than likely, 99.9% of the time, the answer is going to be all real numbers or negative infinity to positive infinity. Now the range, we know range is bottom to top. Bottom to top. So if you look at our parent function, it starts right at the origin or the 0, 0. So my range, when I go to the bottom, starts at 0. And then again, it's going up forever and ever. So that's infinity. So my range is, for the parent function, is 0 to infinity. They can also write it like this. Y is greater than 0. Y greater than because it's going up. Greater than or equal to. All right. Now, this is called the vertex form. Why is it called the vertex? Well, it's called the vertex because when you look at the value of the vertex, you can actually get that from the information in your equation. The ones in the middle will give you the x coordinate of the vertex, and the ones outside of the absolute value signs will give you the y value of the vertex. And we'll do some examples right now. Okay, let's start by looking at the number in front. Okay, so the number in front is referred to as the A. If the A here is plus, or meaning it's a positive, not necessarily a plus, if it's a positive number, then it's going to open upward. Here's our example. If it is a negative number, then it's going to open downward. So our example is y equals 2 absolute value of x. So it would open up, or it's also called a positive function. If it has a negative, so our example here is y equals negative absolute value of x, then it would open downward, and it would be called a negative function. Also, it could be said it reflects over the x-axis. So just different ways they will say that. Next, this is the most important thing you'll need to know for this assignment. So when you go back and look at your notes, this section is what you want to focus on. Okay? So if that number that's in front of the absolute value sign is between 0 and 1, so a fraction between 0 and 1, then the function is going to get wider. So my example here is y equals 0.5 absolute value of x or 1/2 absolute value of x, which is the same thing. So this would become more wide by a factor of 0.5, right? Here it is, by a factor of 0.5. It's also referred to as a vertical compression. Think of vertical compression as if you're squishing a gum vertically, so you're pushing it down. If you push a gum down, it would actually get wider, right? Or like fatter. So that's something to help you remember that wider means vertical compression. Now the next part here. The next part we're going to look at is if A is greater than 1. So it's no longer between 0 and 1. Now if it's greater than 1. So here my example is y equals 2 times the absolute value of x, right? Well, then that would make it become more narrow or skinnier. And it's also called a vertical stretch. So think of a gum, pulling it vertically would make it get skinnier. And if it's the number that's in front of it, that's the factor that it's increasing by. So here it's more narrow by a factor of 2. All right, next section, which is very important and you really need to know, is these ifs. So let's focus on the first one, if h. Well, if you remember, h is going to be from up here, whatever is inside the brackets of the absolute value signs, right? So the number inside, if you have a number that is being added, so a plus h, then it's going to be moving to the left, whatever number is there. If you're going to be subtracting, then that's going to move the whole function to the right, but only if it's inside the absolute value signs. If you have a addition or a plus outside of it, a k, well, it's referred to as k, the number outside of it on the right. If you have a plus, it's going to move it up. If you have a minus, it's going to move it down by that many units, whatever the number is. And we'll see some examples to help you out. Okay, so let me walk you through these right here. I'm going to erase them, and we're going to pretend that the answer is not there, right? I'm going to erase all these, and let me walk you through it. So we have x minus 4 inside. So that minus 4, when it's inside, if you put back, inside is going to be subtraction inside gives it right. So here, we already have the answer, but pretend we would write moves right. So when I'm subtracting, it moves to the right. And then you can see what the graph looks like there on the right, but I asked you to pretend it wasn't there. Also, the vertex always starts with the x value, whatever number is inside the brackets. Well, here our vertex starts at 4, but it's always the opposite. If that's a minus 4, then our vertex has a positive 4. And then our y value of our vertex comes from the number outside on the right. There's actually no number here. You see that? So here it's 0. So 4, 0 is our vertex, and you can check it out here, and that's correct. That's our vertex. Again, remember that if you're not sure, vertex, our domain is going to be from left to right. We're going arrow to arrow, so negative infinity to positive infinity, or all real numbers. And if this would let me write, that would be great. Or that's funny looking R for all real numbers. Range is from bottom to top, so how low does this graph go? Focus on the y values. Most people want to say 4, but no, the y value is actually 0. And how high does it go? Well, it goes to arrow. So our range here is 0 to infinity. You can also just put y is greater than or equal to 0. Also, guys, it's always going to be the y value of your vertex. So here, see how it's the same one? And that'll come from here. Alright, so just giving you some shortcuts there. Let's look at the next one. Again, let me erase this and pretend we don't have all the answers. Okay. We're going to look at the function. We have the +2 outside. Well, outside, if you go back to your notes, you know that that's going to move it up. Where? From our origin. Remember, the parent function starts at the 0, 0. Well, we have a +2 outside. It's going to move it up. So then that's going to change my vertex to 0, 2, just the y coordinate. It didn't move left to right. There's nothing inside with the x. Or if there is something, it's a 0. So it's 0, 2. Then our domain again is negative infinity to positive infinity. Excuse my ugly infinity, or all real numbers. Range is bottom to top. How low does it go? Now it doesn't go all the way to 0. It stops at the 2. How high does it go? Again, that's infinity. Or you can also write it y is greater than or equal to 2. Alright, next example. In this example, you have two things going on at the same time. Oh, one thing I didn't cover in the last one is axis of symmetry. Remember, the axis of symmetry is a line that cuts it down the middle. So down the middle, it's still at the middle of the whole thing. So our axis of symmetry, and I'm going to use AS, is x equals 0. Let's go back up. Down. Now we have a +3 inside, so plus moves it left, right, when it's inside. A +4 on the outside, so it moves up 4, and that's our transformation. Then our vertex, remember, comes from in here, the 3, opposite, so it's -3. And then our y value comes from here, so that's +4, and that was the same one. Domain again is left to right. We go arrow to arrow, negative infinity to positive. In range is bottom to top. So how low does this go? It goes to the +4, and then it goes up, so infinity. We can write it like that, or we could write it as range is y is greater than or equal to 4. If this would be going down, then it would be less than. Okay? All right. Our axis of symmetry, AS, is the line that cuts it down the middle. That would be here, where the x value is -3. So then x equals -3 is our axis of symmetry. Next part. All right, I don't want to rewrite everything, so let's just walk through it. So we actually have 5 things going on. We have a negative in front, we have a fraction, we have a +3 inside the brackets, and a -2 outside. So the negative tells me it's going to open down. So here opens down. Then the fraction is going to be wider, a factor of 0.5, and you can see that it does look wider than the regular one. The +3 inside moves it left, the -2 moves it down. So our vertex is a -3 because we have a +3 inside, comma, -2 because we have a -2 outside. And there is our domain, left to right, all real numbers, or negative infinity to positive infinity. And then range is actually bottom to top, so it's negative infinity to negative 2, because that's the highest it goes. Or you can rewrite it as y is less than negative 2, because we're below the negative 2. Our axis of symmetry would be here. So it is x equals, and it crosses the x-axis there at negative 3. So that's where our axis of symmetry is. Alright, last example here. You can already see it's skinnier, but you see that the function starts with a 3. Well, that's what makes it skinnier. Remember, if there's a number bigger than 1 in front of the brackets or the absolute value signs, it makes it more narrow or a vertical stretch by a factor of 3. Then the minus 2 inside makes it move right 2 units. The plus 3 outside makes it move up 3 units. Because of that minus 2, then our vertex starts with a positive 2, and because of the plus 3 in the back, our vertex, the y coordinate, has a 3. Again, from left to right is negative infinity to positive infinity, or all real numbers. And bottom to top, how low does this go? This goes to the positive 3 here, right? And then goes up, so it goes 3 to infinity, or y is greater than or equal to 3. Alright guys, that's the numbers.